This podcast is brought to you by the AlmaMAC and Scientific Canada. It was recorded on the traditional territories shared between the Haudenosaunee and Anishinaabe nations. Enjoy!
What's going on, everybody? Thanks for tuning back to the AlmaMAC here on 93.3 CFMU. Thanks for tuning in wherever you're getting this podcast, whether it's at CFMU, Scientific Canada, wherever you're streaming it. We appreciate you being here. Thursdays, 12 to 12:30. So on today's episode, the AlmaMAC is pleased to welcome first-year PhD student Konrad Swierczek, who is in the Department of Psychology, Neuroscience, and Behavior under the Faculty of Science. How are things hanging for you over there, Konrad?
Things are good. I can't complain, and I'm happy to be here. Thanks for having me on.
Yeah, well, thanks for agreeing to come on. I'm really excited to learn more about your research. So why don't we just jump right into that? Do you mind briefly describing your research for the audience?
Yeah, so my research is one of those funny interdisciplinary things that McMaster seems to love so much. Largely speaking, my focus is on music, which is a little funny given my specialization. You know, it's a PhD of Science in Psychology, Neuroscience, and Behavior, but most of my days are taken up with thinking about music. My undergrad is actually a bachelor's of music, not a bachelor's of science, which puts me in this kind of funny situation. I did the special music cognition when I was at Mac for my undergrad, and that led me to some really interesting research. Just basically this idea that the way we think about music should be informed more by psychology than anything else. So rather than looking at music from a highly theoretical point of view, or even a physical point of view, we should be looking at it in terms of how does our brain process music? Because the reality is that, music is not this thing that exists in the real world. It's just, a series of disruptions in air. It's physical disruptions in air. That's all it is. When it becomes music is when it hits our ears and starts being processed by the biology, by the brain. So I'm really interested in that, and I'm really interested specifically in harmony. Harmony is the multiple simultaneous notes, basically. Chords is another way we think of it. So melody is a single line of notes across time, whereas harmony is multiple notes across time. And I'm really interested in that and how the brain gives sort of meaning to harmonic structures. Why do composers in certain time periods favor certain structures and not others? And how does our evolving brain sort of influence how that is perceived?
Wow, that's really interesting. And I'm really interested to know, Konrad, what kind of techniques or methodologies would you use to study that, how our brain processes harmony?
Yeah, so there's sort of two rough approaches in the field right now. The first is sort of in the more conventional psychology realm, which most people listening to this are probably familiar with, because most people have gone through a psychology experiment at some point in their university careers, whether it's that psych course that you're taking for an elective and, you get the extra credit for taking a psychology experiment. So that's sort of the most typical methodology we use. And actually, a colleague of mine in the digital music lab puts it really well. She always describes her work as playing bad music for people just to see what would happen. So in this sort of psychology realm, we'll create stimuli where we manipulate certain independent variables to test a hypothesis. And we basically play that for multiple participants, and there's some sort of dependent variable, something that we're measuring. Oftentimes that's a subjective rating, on a scale of 1 to 7, how much closure do you perceive from this passage of music? But I'm really interested in trying to find objective measures, so measures that don't rely on conscious attention. Is a reaction time study. There's a technique called semantic priming where, words are presented to someone And then those are prime words, and then there's a target word. And your reaction time to that target word is an indicator of how well the previous words have primed that target word. So, if I was to say hospital, bandages, surgery, and then I was to say nurse, you would be highly primed by those previous words. Whereas if I was to say those same prime words, hospital, surgery, bandage, and then say giraffe, your reaction time would be slower to that, because obviously giraffe has not been primed by these words involving healthcare.
Right.
So we're doing a similar thing with music right now, where we basically measure the reaction time that someone has to this target chord after playing a prime sequence. And that's sort of the objective side of things. So no one is actually thinking about the question we're asking. So we're able to get to this very unconscious, implicit knowledge about music. So that's sort of roughly the first category of things. And the second category, which is quite popular, is what we call corpus analysis, where rather than looking directly at the perception of humans, we look at the composition of music as a sort of proxy for how people perceive music. So we say, okay, if we analyze every single piece of music that Ariana Grande ever wrote, which is something I'm actually doing because I'm really interested in the harmony of Ariana Grande, then we can look at sort of the statistical regularities in that music, what patterns occur quite often. And based on those patterns, we can sort of infer that some patterns are more present in music perception than others because of how statistically regular they are in a piece of music. I know that can be a little confusing, so I hope I've explained that clearly.
No, yeah, that was really interesting. So going back to that first methodology that you broadly described, especially with semantic priming. So is the idea that if you present, chords that are similar to one another or maybe harmonious, the participant would have a quicker reaction time to identifying the target?
Yeah, exactly. That's exactly it. And there's some early study that was done before I became a graduate student, that actually in the early 2000s, that looks at that and basically finds that when they presented sequences of chords in the prime that were structurally related to the target, they got a faster reaction time than they did for chords that were not related. And it was sort of a very surface level discovery in a way. It matches up to our intuitions very, very well. I'm sort of interested in stretching that a little bit further, because it turns out, and this is kind of a segue into some of my deeper interests in this field, but it turns out that our definitions of what fits musically and what doesn't fit musically are actually highly arbitrary and not empirical at all. And based on historical precedents that don't necessarily exist anymore, or that do exist. I shouldn't say they don't exist anymore. It's historical precedents that were 100% true 200 years ago. But music has changed a lot in the past 200 years. You listen to music 200 years ago, and there's certain things about it that are very familiar, but there's other things that are completely foreign to us. And conversely, if I was to go back in time and play Ariana Grande for Mozart, he'd be shocked just by the harmony, not even talking about, any of the other features of the music, the electronic side of it, the texts and everything, but just the harmony itself would shock him. And that has to be taken into account. And I think that we need more empirical studies that look at how some of these things change, because some of these early studies with harmonic priming sort of reinforce this idea that, these very basic musical structures are familiar to us. But when you start modeling them and put them against more modern music, I keep coming back to Ariana Grande, but it's a great example because there's a lot of complexity in her harmony, and there's a lot of influence from all sorts of different kinds of styles. It doesn't hold up. It doesn't account for this missing contemporary feature. And I'm really interested in what that is. And I have some hypotheses as to what that is. But I sort of want to refocus what the field considers to be the structure of music on the contemporary structure of music, not the ancient structure of music.
Mm-hmm. And I know in our little pre-interview, we were kind of mentioning maybe, or how you were talking about how these historical, I guess, influences, they may come from a primarily Eurocentric bias. And now you're advocating and saying, no, it should be empirically based. So if you want to speak to that a little bit more, I'd be interested in knowing.
Yeah, it's a fascination of mine, and sometimes
Yeah.
I feel a little guilty because I have some colleagues who are doing work similar, on a similar vein, but they're doing it in a much more broad sense. A very good colleague of mine, Elizabeth Phillips, who's also in the department, she studies the cross-cultural development of musical scales. So it's in a much more broader sense. I specifically study Western music in a way. But when I say Western music, that's not really quite satisfactory. When I think Western music, I think old white dudes that died 200 years ago.
Right.
Which is a problem. It's a big problem the field has, right? And it's a big problem music theory has. A lot of the way that sort of North American and European musicians and music thinkers have thought about this for a long time is by through the lens of white men who died 200 years ago. And even within my vein of studying so-called Western music, that is music that is largely created, in North America and Europe, South America to some extent as well, and worldwide, the influence of sort of the Western music canon has stretched far and wide, but it's morphed in that time. Another great example, I'm not an expert on it, but another great example is Bollywood, right? Like Bollywood music is highly influenced by Western structure, but it's also not at all. Like it's these fusions. You get these fusions, and that's why I don't like the term Western music. But I guess the idea here is that we need to be divorcing ourselves from these 200-year-old, and sometimes longer. Some of these theories are 500 years old. Theories that don't really work anymore, and are highly Eurocentric, and in some cases come from places of... They're problematic, at least. Like some of these theories are not particularly... They're not thinking about equity. They come from a different time, and I can't speak to whether these old white men that died 200 years ago were doing this in a racist framework or anything like that, but it certainly feels that way today. And I'm really interested in this idea of having a theory of music that is completely empirically derived and doesn't depend on theories of music from 200 years ago. And sometimes I look at work being done in this field and I see this tendency to go, well, let's empirically prove the existence of structures that were theorized 200 years ago by some random white dude, right? And that just seems problematic to me.
Mm-hmm.
So, yeah, I guess it sort of involves blank slate in a way, trying to approach it. And it's tough because, like I say, I have a bachelor's in music. I was trained in the Western music tradition, but sometimes you have to sort of approach it with blank slate and say, let's forget everything we know about this and really get down to what are we hearing.
Mm-hmm. Mm-hmm. Yeah, I love the degree of rigor and empiricism that you're bringing to your research. Just out of curiosity, do you know what the literature might say about this cross-cultural variation in music perception or its differences in harmony across these different cultures? I'm generally interested in knowing that.
It's spicy.
Okay.
It's a spicy debate. Cross-cultural research in musicology and in music cognition has really blown up in the past 30 years. And there's some amazing work being done right now to sort of level the playing field a little bit. People that have realized that we've been focusing far too much on Western art music for far too long. And I say Western art music specifically because it's not just about, it's not just a cross-cultural issue. It's also a classist issue, right? Where the Western music that we focus on from Europe is Western art music that was preserved because of wealth, right? The reason we listen to Haydn, we listen to Mozart, we listen to Beethoven, is because that music was preserved by, largely speaking, European monarchies that were patrons of these composers and, codified their music in a written form. That changes a little bit in the 19th century, but that's really where it comes down to. So it's not just about the cross-cultural thing. It's about also examining folk traditions. Those are European folk traditions, American folk traditions, and of course, cross-cultural folk traditions. Looking at the entire musical experience of humans, not just a select part of it. And the cross-cultural consensus seems to be that there are musical universals, but very few of them. And, I attended a conference recently where one of the most influential authors on this made a point where he said there are some statistical universals, but not complete universals. They're nearly universal, but it's sort of hard to tell how much of that is actually, biologically innate, and how much of that is something that just has been learned, right? The holy grail of this has been finding populations that are untouched by Western music. But there has been some success in that. There's a population in Bolivia, I believe, called the Chimane, and they are virtually untouched by Western influence. And so a research group has gone out there and done some work with them to see whether certain things that were thought to be universal are universal or not. Out that a lot of these things that we had historically thought were universal are not. But it's tricky because you see certain things cropping up where it seems like some things are universal and some things aren't. And it's a spicy debate, like I said, and it's sort of tricky to take apart which bits are universal and which bits are influenced by culture and which bits are, something more abstract like technology, because technology has certainly played a role in what the structure of music is. It's tricky, but it's a very interesting line of work.
And just briefly, I also wonder if individuals with congenital conditions, for instance, as you know about amusia, people who are unable to detect pitch, if that might also be an interesting population to study.
For sure. Not my specialty, but I actually I'm working on a project right now, a sort of side project that will feed into my larger project on something called Dissonance, which might be a familiar topic, might not be. It's basically this idea that some sounds sort of clash when they play together and others, don't, And congenital amusia has been used to study that because starting in about the 1860s with Hermann von Helmholtz, who's very influential, sort of early psychologist slash, psychophysician, I guess, sort of had this idea that it was related to the interaction of sounds on the ear rather than anything in the physics of it or anything in the brain. And that theory has been tested until about 2006. That's the last time I can see someone writing on that specific topic. Not exactly sure. There's some papers in 2019, but it's a little broader than that. And congenital amusia was used to see how much of that is actually in the sort of sensory apparatus or your ear versus how much of it is in your brain. Or again, in other words, is this something that is learned or is this something that is baked into our physiology? And I'm not an expert in amusia, but it's work that's being done and it's interesting. And, even just trying to pick that apart is tricky, but, that's largely how a lot of sensory versus cognitive things have been picked apart. Again, this nature nurture debate, a lot of that has been solved in other fields of psychology through lesion studies, right? Through studying people who don't have a neurotypical brain, whether that's because of, congenital disorders or whatever it is, or whether it's more based on accidents that they've been through. But studying those kinds of conditions can give a lot of insight into these issues.
It's fascinating. Konrad, you've obviously thought a lot about this, and I can just see the gears turning in your head, as you continue to read the literature. But I'm curious, what do you expect are some implications or even applications of your research findings?
That's where it gets sort of fun, I think. I mean, it's all fun, but that's where it gets really fun for sort of the average person. Because, we're looking at these individual elements of music and we're trying to figure out to what extent do they influence the perception of harmony, right? Because harmony is this top level structure. You can think of it that way. It's the combination of multiple different elements, whether those are physical elements or sensory elements or perceptual elements, and they're all coming together to form this sort of larger thing that we call harmony. So we come up with all these individual components and see to what extent they influence the perception of harmony. But what's sort of the logical conclusion of that is a model, a model which predicts the perception of harmony. So to be able to say, and again, this is where that Western side of it comes in. My model would mainly work for people who are encultured in Western music, which at this point is a lot of the world, but still, it's not the same as a model of, let's say, Carnatic music, Carnatic harmony, which is something that that's South Indian, I believe, which is something that my lab has done as well. But this would be a model specifically of sort of Western, with all those fusions, influences of jazz and everything. But it's a model which predicts that perception. And that gets really exciting because now we're basically teaching a computer how to listen to music. And I'm sure many of your listeners are familiar with, automated generation of music, computers that are writing music, and it's quite boring and it's not really great. And, it ties into that. I can imagine application of these kinds of models going into automated generation of music, which is really cool. The better those models get, it's sort of a litmus test. The better a automated generator of music gets, applies, the more we understand about that music, which is pretty cool. But there's also a burgeoning field of music information retrieval, which people might be more familiar with in the form of the Spotify algorithm. How does Spotify say, okay, you listened to this music, and this music, so we're going to direct you to this music. And, largely the way Spotify does that is by saying other people who listened to this music like this music, therefore you will like that, which is another fascinating line of research in terms of how personality lines up with your musical preferences, which is also being done in my lab by a graduate student named Maya, who I'll shout out now. But there's sort of some new approaches to this algorithmic music selection process, which is, well, maybe you like this music, but why do you like this music? What parts of the structure are making you like this music? And the sort of end conclusion from that is, if we can find certain features in the acoustic waveform that we think correlate with people liking it, then we can match that to other music that is similar. So that's been done with things like, instrumentation, where if you like music that has this kind of instrumentation, you will probably like music that has other kinds of instrumentation. But a part of me puts on my thinking cap and thinks, shouldn't that be the same thing for something like harmony or the structure of music? If you really like the kind of harmony that's used in jazz, shouldn't you like it in other kinds of music too? I don't know. I'm not sure yet, but I think that would be an interesting application of the model, and I'd love to look into that. The boring side of it is it helps us understand music better, in a way that I hope trickles down to education, and this ties back into the sort of, taking out the Eurocentrism, or the ancient Eurocentrism out of music and out of music education, and starting to say, well, obviously we're not going to teach it on the level that, on this advanced level where we get into the math and into the cognition and everything. But if there's patterns, and that's how we're hearing the music, shouldn't that be how we're teaching it? I think about my second year undergraduate harmony class, where you get to this point in a second year undergraduate harmony class, and they start throwing the weirdest names at you for chords. You start looking at these special chords, and their German sixths, and their French sixths, and their Swiss sixths, and their augmented sixths, and their diminished fifths, and this and this and that. And the city names drive me crazy. Neapolitan second, or the Phrygian two. It's like, what are we talking about here? Some white dude 200 years ago thought that this chord sounded like Naples, so he called it the Neapolitan. What are we doing? That has no relevance to me. Whereas, certain fields like jazz have sort of gotten to a better place with that, where they're starting to understand that if you can map it onto how you actually hear the music, it makes more sense. What classical musicians call a German sixth, jazz musicians call a tritone substitution. And functionally, that makes a whole lot more sense. Might not make a lot of sense to a lot of people listening to this, but if you understand sort of how the music is working and you've studied it, saying German sixth isn't relevant. Saying tritone substitution is relevant. And so I think that my work could have that influence on music education and say, no, we're going to stop thinking about this from a historical point of view and start thinking about how we are perceiving music now.
Mm-hmm. Mm-hmm. A lot of varied and interesting applications. Thank you for sharing all those, Konrad. Okay, so Konrad, you showed us your keyboard earlier, and at the beginning you mentioned that you had a bachelor's in music. So, I mean, we have to talk about your interests outside of academia, because you yourself are a musician.
Yeah, and I think that's important. I won't rant about this, but I think that if you're doing research on music, you should be a musician. It's important. It's important to have that application. But I was brought into research because I was a musician, not the other way around. So I didn't start in research. I started in music. And, I often say that, I could walk away from research right now and just go back to playing music. But it's a part of my life that I still, really, really work on. I'm a bass player. I play electric and double bass. But I also noodle on piano. I played piano a lot more when I was younger. But it's, still a great tool. I think of it more of as a tool these days than as an instrument. It's good for, writing and getting ideas out. But my first instruments are the bass, the electric, and the double bass. And, I play all sorts of music, jazz, rock. As of today, I have a single from one of my music projects that just came out. It's a sort of indie rock band, I guess, folkish, kind of hard to describe, but that just came out today, so that's exciting. But I also do a lot of more technical work in the music world, recording engineering, mixing, that kind of thing. A lot of designing sound systems and things like that, which is a big passion of mine. I really love working with technology, and I really love bringing other people's musical dreams to life. It's really exciting. It's fun playing music and everything, but I've always thought of myself more as a sideman. And I love, both in playing and in the technology, I love bringing people's work to life.
I love that. And I also love how you highlighted that, as researchers or graduate students, we need to have this innate love for what we do, because, the field of academia is so hard. It's failure after failure. You have to love what you're doing, and only that's just going to bring you pure joy. Yeah,
exactly. I can't imagine doing research if I wasn't as passionate about the subject as I was, because like you say, there's so many little things, grant applications, dealing with coursework, dealing with this, dealing with that, and it's never ending, and it's not fun. No one likes writing grant applications. I really hope there's no one out there who likes writing grant applications. But remembering that you're doing it because you want to be able to do this fascinating research that you just inherently love is so important.
Yeah. And let me tell you, Konrad, your passion is palpable. It has just been so wonderful chatting with you about your research interests, your academic interests, your lifelong interests, and kind of how they've been this common thread throughout. So thank you for sharing that with us today.
Happy to do it. It's been great being on.
Great. And thank you to all of you who are listening here on 93.3 CFMU. We'll be back next week with another McMaster graduate student, but until then, take care. Bye, everyone.